All right, all right. So I'm gonna say welcome back to uh, chemistry. This is Evans Lukomona, Central Hamburg University, and I've got students, grad students from Zambia. They are doing their first year um, science faculty of course, and they've got a combination of chemistry, biology, physics, mathematics, and I believe IT. Now, yesterday we couldn't record because of technical faults. I don't know what happened. It was full actually, but today we're able to record. So we're gonna have a 1 full hour of lecture. Please, students, take your pen and your paper and make notes. Just take important points. That's the meaning of a lecture. You coming to participate when we come to a tutorial. Tutorial means questions and answers, what you didn't understand, and kind of stuff. Now, yesterday, first and foremost, we are still doing organic chemistry. Okay, so far we've looked at the hydrocarbons, and I did emphasize a point to say when it comes to hydrocarbons, okay, you've got to pay attention onto the first family, that is the alkanes. Alkanes are characterized by the carbon-carbon single bond, and the nomenclature, the naming of alkanes, okay, goes to being copied by the naming of the compounds under alkenes, also under alkynes, also under alcohols, also under carboxylic acids or organic acids, esters, and so on and so forth. So, meaning the alkanes, okay, I would call the alkane family, okay, the alkane family with the characteristic of carbon-carbon single bond. Of course, here hydrogen, hydrogen. This structure and others to come, okay? Of course, remember the simplest structure has got one carbon, which is methane, okay? Or ending A-N-E. This is what we discussed in the nomenclature or naming of alkanes. The second simplest compound is called ethane. The third with 3 carbons, okay, we said propane. The fourth, butane. Fifth, pentane. Sixth, and so on and so forth. So the way we name here the alkanes, the hydrocarbons called alkanes, is the same way we're going to, okay, name similar, not same, the alkenes, okay? An alkene, for instance, when you come to alkenes, an alkene with double bond here is not going to be ethane, it's going to be now ethene, okay? An alkene with triple bond from propane is going to be propene. An alkene with four carbons, 1, 2, 3, 4, from butane, is going to be butene. So E-N-E, E-N-E, E-N-E. And we talked about the derivative formula, okay, and kind of stuff. And I mentioned that if you miss the first part of organic chemistry, wherever it takes you, the alkanes, you risk getting confused along the way on nomenclature. Nomenclature means how to name such compounds. Okay. Now, yesterday we also looked at the arenes. Okay, arenes. that form the aromatic system. The aromatic system, the arenes, these are now cyclo, okay? They form the rings. They are not like aliphatic or stretch chains, okay? The arenes are represented in this case by a compound called benzene. Benzene, which you know, is represented by the ring form 1, 2, 3, 4, 5, 6. Okay, that is benzene, where here carbon, 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 6 carbons. All right. Or if not, we said yesterday, in this form, it's going to be represented by the structural form. Okay, still benzene. We are going to say double bond, you skip, double bond, you skip, double bond. And here it's going to be carbon, 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 every corner with carbon, okay? And the equivalent number of hydrogens here, 2, 4, 6, 7, 8. 2, 4, 6, 7, 8. Sorry, carbon here, 2, 4, 6, 7, 8. 2, 4, 6, 7, 8. 2, 4, 2, 4. Okay, it's supposed to be all the time surrounded by 8 dashes. I mean 8 atoms. Okay, so 2, 4, 6, 8. What am I doing? I think I'm tired. Too much teaching. Sorry. 2, 4, 6, 8. Great. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. Remember each dash, that's why I'm saying 2, has got 2, is represented by 2 electrons. Okay. Oh, that's Mr. Shirley trying to call me. All right, so which simply means 1, 2, 3, 4, 5, 6. Hydrogen, 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 hydrogen. And we said the formula is 1, 2, 3, 4, 5, 6. C6H6. This is the formula of benzene. Okay? This is the formula of benzene. Now, I even said why called aromatic, coming from the aromatic system, because benzene and other family compounds, they smell like nicely. That's why, you know, like aroma in our food stuff. Okay, it's the aromatic system. Then also yesterday we looked at let's forget about the hydrogen. They're taking too much space. Okay. So if a benzene, let's save space. If a benzene, okay, I'm going to do that. 1, 2, 3, 4, 5. This way smartly. No, got to be artistic. Yeah. 1, 2, 3, 4, 5, 6 presses. Now, we all know carbon, carbon, hydrogen, and kind of stuff. If on a carbon comes this here, okay, the ethyl, methyl, okay, the methyl group. Remember from methane, okay, from methane, which is C4 hydrogens, okay? When we pluck out one hydrogen by some chemical reactions, don't worry, we are just discussing the structures. When we pluck out one, there's a deficiency of one hydrogen, it changes from methane to a methyl, okay, methyl group, okay. This is a methyl group now, or HC3, with a hanging electron, trying to find another electron, okay, to be attached to for completion. So it's called a methyl group. So in this case, we bring the methyl group. This is an electron from here. Then comes a methyl group with its electron, okay, forms a bond, okay. So this is no longer a complete benzene compound. It becomes methyl benzene, okay, methyl benzene. If we pluck out this group here, the methyl group, okay, the methyl group out, we bring in a chlorine atom. This is gonna change from methyl, you name this first, chlorobenzene. That is chlorine into a benzene, okay, chlorobenzene. If we remove this, we bring in a bromine. You still remember from group 7, the halogens, yeah? The bromine is going to be bromobenzene, and so on and so forth, okay? Later we're going to have a look at if you've got more than a foreign atom, how do we name them and kind of stuff? Very easy. So that's what we looked at. Now, today, I would love us to continue on the compounds that are called isomers. 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 Okay. What are isomers? Isomers are compounds that have got the same molecular formula, but different structures. Okay, same molecular formula, but different structures. Simple as all that. Now, look at that. For instance, okay, for instance, now you are masters of hydrocarbons. I'm gonna draw a structure of an open structure of an alkane with 1, 2, 3, 4, let's say 5. Remember, hydrogen, 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 okay? And here. This is 5 carbons, it's called pentane, okay? Pentane. Now look at this structure, okay? 1, 2, 3, 4. And the carbon now comes in. Forget about the hydrogens, okay? I don't want to cluster the stuff. You all know. Here, how many hydrogens here? Of course, 1, 2, 3, 4. 1 here, 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 and here, okay? So my interest, or our interest, is to have 2 different structures. Structure 1, let's call it S, ST1, ST2. Now look at this. What is identical? Of course, this is also pentane, okay? By virtue of counting 1, 2, 3, 4, 5. Even here, 1, 2, 3, 4, 5. But how do we differentiate? The one with a branch, this is a branch. and the compound without a branch. Okay, so this is a normal pentane without a branch. And look, its molecular formula, it is C 1, 2, 3, 4, 5. 5. How many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. And remember the formula yesterday? We said formula for alkanes is like this. Plus 2. So number of carbons, you just place here. 5 carbons, 5. 5 comes here, times 2. Sorry, I'm writing 10. I'm getting tired. So 2 times 5, 10. Plus 2, 12. Okay? This is the molecular formula of whether it's an isomer or no isomer. All right? An alkane with 5 carbon atoms, which we are calling pentane or normal pentane. Then comes also here 1, 2, 3, 4, 5. C5. How many hydrogens? 1, 2, 3. Remember, surrounded by 4. 1, 2, 3. 1, 1, 2, 3, 4. Surrounded by 4. Still, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You get a point? Still the same. Now, how do we differentiate that this is an isomer by virtue of its structure? Therefore, the nomenclature or the naming is going to change for this one. Okay? How do we do the naming? Point number 1, write down this. How do we name an isomer? Naming, 1 second. Mr. Shobe, can you see I'm in class?
Hello.
Ich bin in der Klasse unterrichten nachher. Okay. And he keeps calling me, so I have to show him I'm busy. That's my colleague. And naming isomers, okay? Naming isomers. Number 1, how do you name? First, identify the longest carbon chain. Okay? Identify the longest carbon chain. Then 2, identify, okay, the branched, okay, chain or substance. All right. 3, then name the isomer, okay, with the longest chain, okay, sorry, okay. Then name the isomer with the longest chain bearing the main name. Okay? The longest chain bearing the main name. Now, what do I mean here? This is what I mean here. Here, so easy, yeah? Now here, identify the longest chain. Which one is the longest chain? Number 1. How many chains we have got? 1, 2, 3, 4. This has got 4 carbons, okay? This is also a chain, has got how many? 1, 2. No, it's shorter. Any other branch nothing. So it's either you take this one or this one, but always take the longest chain. So what is the longest chain? And name the longest chain. So this is my longest chain. 1, 2, 3, 4. Okay? It still could be 1, 2, 3, 4. It's the same. Okay? So I'm going to take this one as my longest chain. Then this is going to be a branch. Okay? So what's the name? Name the longest chain. The longest chain now becomes 1, 2, 3, 4. A hydrocarbon, which is saturated, or a alkane, because of single, it's going to be whatever I'm going to write in front. The longest chain has to be the main name, butane. Okay? Take note, butane. So I've named the longest chain as butane, but in front you put the branch. Okay? What's the branch? Here. What's the name of the branch? Remember, complete, 1, 2, 3, 4. It is methane, isn't it? That's what we wrote. Okay, remember, 1, 2, 3, 4. This is methane. The moment one had, okay, let me do this. Okay, originates like this. So when we pluck it out, okay, one hydrogen here is going to miss out, isn't it? So it becomes CH3 with a lone electron, is it? And from methane, it becomes, this one now becomes methyl, okay? Methyl, because it's not a complete now methane structure. So this is called the methyl group attached, methyl. So you're going to say here, methyl, okay? Methyl butane. This is the name of the isomer, methyl butane. You get a point, okay? Methyl butane. If you want, you can also indicate on which carbon is this methyl group attached. On the second or on the third? 1, 2. So carbon 1, carbon 2. It's attached here. Or I can say it is attached on, if I start counting from here, never mind where you start counting from, okay? Here, 1, 2, then comes the methyl. But if I count from here, 1, 2, 3. In chemistry, the UPAC system, okay? Take the shortest distance covered, okay? This is longer, 1, 2, 3. So we are going to go with counting from here, 1, 2, okay? So I can say this is 2 dash methyl butane, okay? Meaning the methyl group is attached on the second carbon. You get a point, okay? It's attached on the second carbon. If you do it this way, 3, it's gonna be wrong. Structurally, it is correct, but follow always the shortest distance counted. We're together, okay? Very good. Now, this is the compound. So we can say this is false, yeah? 2, or sometimes dash. 2-methylbutane is an isomer of the original butane or normal butane. Okay. Butane forms some simplest isomers, but they are are some long chains which can form more isomers. Quickly, let's have a look at that. Okay. Let's have a look at that. Mind you, I'm talking about isomers in hydrocarbons, just carbon and hydrogen. There will be isomers in haloginoalkanes, that is halogens, the seventh group, chlorine, inside, chlorine changing positions and stuff, but it's so easy. If you understand here, you have understood where we are going to as well. Now, look at this. Let's change, take some longer compound. Let's say 1, 2, 3, I think you're able to see, 4, 5, 6, okay? Let alone, okay, let's do this one. Don't forget, hydrogen. When I'm teaching, I'm not putting hydrogens, okay? But when it comes for you to answer questions, add hydrogens. Or you can just put a disclaimer to say, if you don't want to put hydrogen, just say each dash contains a hydrogen atom. Then the marker understands. All right. Now, 1, 2, 3, 4, 5, 6. Already you are masters of nomenclature. This is an alkane code. 6-sided polygon. You remember yesterday? You name according to the polygons. A 6-sided polygon is called hexagon, isn't it? So in chemistry, this is going to be hexane. Okay? Hexane. This is the compound with molecular formula. Okay? So we're going to do first compound, C6. How many? H. You remember the formula? We said like this, plus 2, isn't it? So 6 here, 12, plus 2, 14. So we're simply saying these are 14 hydrogens that are surrounded. Now, let's see the different types of isomers that we can create and how to name them from this compound. So, itself is an isomer, okay? First isomer, the original, normal hexane. Second isomer, let's drop to 5. 1, 2, 3, 4, 5. Okay? From 1, 2, 3, 4, 5, 6, drop 1. Okay? Please don't make a branch from the first carbon. No, 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 no. Always when you branch, because if you put here like a branch, no, it's the same as this one. Because when you stretch it, it's going to become like this. Then you haven't changed anything. That's where all the time the branching should happen on the second carbon. Okay, that's the shortest distance. The second carbon is called the secondary carbon. Primary, secondary carbon. Okay, we're going to talk about that later. So 1, 2, 3, 4, 5. Then drop here. If you want, drop here. It's the same compound. Okay, it's the same. Now let's check. This is the second one. Let's check. Can we create another third one? I think so. From 1, 2, 3, 4, 5, I'm going to drop to 4. 1, 2, 3, 4. Okay. I maintain this one here. Then I take this one. I bring it here. Yes. So we've got 1, 2, 3, 4. And branch, branch. Can there be a possible fourth isomer or fourth different structure of the original hexane? Let's try the fourth to say 1, 2, 3. 1, 2, 3. It doesn't work because if we bring here down, this one down, it doesn't take us anywhere. We do this, is the same as this one coming here. It takes us, okay, to the other one. Let's see, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. We shift this. Yes, in the middle. This is different from this one. Okay, very good. Now, we are simply saying at this point, hexane can give us how many isomers? One itself is counted as well. 1, 2, 3, 4. So this is 6 carbons, 14 hydrogens, the original. Even this one is the same. Even this one is the same. Even this one is the same. All right. Sorry, 14, not 16. It's the same, but different structures. Therefore, each structure is going to be named. This one is named normal hexane. You can even say normal hexane. The next one, we have to position, okay, the branch. But before we position the branch, let us name the longest chain. What's the longest chain? 1, 2, 3, 4, 5. Okay? We can count 1, 2, 3, 4, 5. Or from here, 1, 2, 3, 4, 5. But remember, the branching has to take the shortest distance. Okay? So, before you go to the branching, let's give the name of the main name. Okay? The main is going to be 1, 2, 3, 4, 5. Which is pentane, isn't it? 5-sided polygon is called pentagon. In chemistry, pentane. So pentane. This is how this compound is going to end in nomenclature, in naming. Now, what's the foreign body or the branch? It is this group, isn't it? Remember, this is CH3. We said the CH3 is from methane complete, isn't it? 1 hydrogen away remains with 3 hydrogen. It becomes methyl, okay, group. Unstable. Why unstable? Because one electron is hanging. It has to combine with another one for stability. So after you've named the longest, which is pentane, you come to naming this group. So it's going to be methyl pentane. But where is the methyl attached? On the fourth, 1, 2, 3, 4, or on the second, 1, 2. We always go for the shortest distance. So it's going to be 2-methyl pentane. Okay? 2-methyl pentane, meaning methyl is attached on the second carbon. Okay? It's attached on the second carbon. And we are going to say if this is the second carbon is always called secondary. First carbon primary, secondary. Okay? Very good. And the nomenclature is done. Let's go to the third. Third, as well, start with the longest chain. Name the longest chain. Okay? What's the longest chain? 1, 2, 3, 4. If you count 1, 2, 3, 4, it's the same. When you do it, this comes up. Okay? So the longest chain is, I hope you are able to see. The longest chain is 4 carbons. 4 carbons. An alkane with 4 carbons is called butane. Don't forget, butane. So we have built the main anchor, okay? The mother of this compound is butane. But then what are the foreigners or what are the branches? Remember, this is CH3, CH3, isn't it? What's the name again? Methyl. So we've got methyl 1 and methyl 2. Okay, not by chains. I just mean number 1, number 2. Okay? Now, for the sake of space, let me remove this. Okay. When you have got 2 similar branches or 2 same branches, don't just write methyl like we did here because it's alone. Okay? 2 in organic chemistry, 2 we say di. Okay, that's 2. Okay, 3 tri. Okay, 4 tetra. Tetra. Okay, now these methyls are 2. So let me just say this like this. Methyl. So you count, how many are they? 2 methyls. So we are going to say dimethyl butane. Okay. Are you able to see where is dimethyl? Okay. Perfect. I hope you are getting that. Number 1, this compound is not yet finished. Okay, it's not yet finished. Number 1, figure out the longest chain. Longest 1, 2, 3, 4. Name it. Butane. Okay. Number 2, identify the name of the branch. The name of the branch in this case is methyl. Okay, methyl. But how many methyls? Identify the appearances of the branches. If it's the same, just say di, since there are 2, 1, 2, dimethyl. Now, for the bone of contention, you can leave it like this, but let's position. Where are they positioned? Okay, the positioning of the methyl. So longest chain 1, 2, 3, 4, or 1, 2, 3, 4. So if you count from here or from here, it's the same. So we are going to say the first methyl is positioned at 1, 2. So you are going to write 2, comma. Okay? The next on the third. Don't say, oh, Mr. Lukomona said the shortest distance. So here I'm going to start 1, 2. I write 2. Then shorter here is 1, 2, 2. No. If you start from here, go straight on. If you start from here, go straight on. You get my point? So 1, 2, comma, which is the next number? 1, 2, 3. 3. 2, comma 3, dimethyl butane. That's the nomenclature. 2, comma 3, dimethyl butane. Now look where we are coming from. From a simple stretch chain, giving us some complex nomenclature. And this 2, comma 3, dimethyl butane, some properties, when we come to physical properties, okay, and chemical properties, they will be different from the normal butane, okay? They are mainly similar only in molecular formula, C6H14, C6H14, 6H2, but structures different and behaviors different. We're gonna come to that. Remember, this point we are doing the structures and nomenclature. Now, we have named this one here. Let's go to the last one. Okay, I'm gonna erase so that we've got a clean space. Still maintaining the mother compound. Now, 1, 2, 3, 4, 5 in the middle. So 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. So no matter where are we? Yes. No matter whichever way we take, it's going to be the same. From here on the third. From here on the third. So remember, we've only got one methyl attached onto the third carbon. So we are going to name this one the longest. 1, 2, 3, 4, 5. Pentane. Pentane and one. The branch is methyl. Methyl pentane. But where is this methyl placed? On the third. So 3 dash. Methyl pentane. As simple as all that. As simple as all that. This is isomerism or isomers. Isomers are substances or compounds, but the process or the behavior is called isomerism. Okay? Normally, students fumble. A question comes, what are isomers? A, what are isomers? B, what is isomerism? Students answer the same way. What are isomers? Isomers are organic compounds that have got the same molecular formula but different structural formula. Isomerism now becomes a tendency or a behavior. Isomerism is a tendency where organic compounds tend to have the same molecular formula and different structural formula. Just that gives you a differentiating definition or response or answer and gives you a full score of marks. You get the point, okay? Very important. Now, let's quickly have a look at some isomers. We're going to take what is called Hologinoalkanes. Okay, halogenoalkanes. What are halogenoalkanes? Halogenoalkanes, you can tell, these are substances that are made up of halogen and hydrocarbons. So we expect 3 elements: carbon, hydrogen, and a halogen or halogens. It will be chlorine, bromine, iodine, fluorine, and so on. That's all. That's why they are called halogen. Coming from group 7 of the periodic table, you remember group 7. Okay? Now, let's have a look at this. Okay? It can be attached on the first, the chlorine. Let's use now iodine, okay? Remember iodine molecule is like this, isn't it? Iodine. Okay, this is a iodine molecule. So, iodine is attached here. What will be this compound? Okay, in general, iodine in 1, 2, 3, 4, butane. That's the main, okay, name. So you don't write iodine butane, no. Iodine in organic chemistry is abbreviated as iodo, okay, iodo. So this is iodobutane. In general, it's iodobutane. But it is also bound to form isomers. You know what isomers are? Different structures. Iodine can come here, which is the same as iodine being here. or this carbon can come here and iodine. It becomes an isomer. Same molecular formula, different structures. You get a point. Okay? What's the molecular formula? 1, 2, 3, 4. 8. 8. 8. So hydrogen 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be C4H. How many hydrogens? 9. How many iodines? 1. Okay? 1. This is the molecular formula. So now to complete the nomenclature or naming of this haloginoalkane, okay? Sometimes, by the way, they are called halo, just halo, haloalkanes, okay? Haloginoalkanes or haloalkanes, it's the same. Now your masters, branching, you can count where it's branched, 1, 2, 3, 4, or 1, 2, 3, 4. So can we call it is on the fourth or it is on the first shortest distance? Okay, so we are going to say 1 iodobutane, 1 iodobutane, meaning the iodine in this substance is attached on the first carbon. All right. If now we said, okay, let's shift the iodine on the second, or whatever you call it. Let's remove these dashes. Okay. Still the same formula, isn't it? We have just changed the position of iodine. Where is it positioned? 1, 2, 3, 4, or 1, 2, 3, 4. Is it on second or third? Shortest distance. So this one is going to be 2-iodobutane. That's another compound. We just came from 1 iodo now to 2 iodo. But if we shifted it to here, don't be carried away to say 1, 2, 3 iodo. No, then the shortest is here. 1, 2, still 2-iodobutane. You get a point? Perfect. Now, on the same, let's play around. 1, we said 1, 2, 3, 4. Okay, this is the original. It was here. So this is the first isomer. Okay. The second, we said 1, 2, 3, 4. It came here. All right. Let's check out the third isomer. Now we are going to disturb the chain. Let's make the carbon-carbon chain. Let's disturb it. Okay. Let's that's too much. Let's do it on top so that I've got space here. Now let's do this. 1, 2, 3, and this guy comes here. Okay, it's still 1, 2, 3, 4. 1, 2, 3, 4. We are there. Let's put this one here, the iodine here. Then next, let's put the iodine here. 1, 2, 3. Iodine comes here. Same molecular formula. Same molecular formula. Let me do this. Same molecular formula, different structures. Now let's check. Nomenclature, naming. We're going to name this one. Okay. 1, 2, 3. Not 1, 2, 3 because it's attached here. So this is first, write the main name of the longest chain. 1, 2, 3 is pro. 3 carbons. Remember from propane. Propane was gonna be here. Okay. Very important. So we've got one iodo. This is iodo. Don't forget iodo. Okay. This is, remember, methyl. Okay. I'm going to take the simplest count on one. One. What is on the first is iodine. So one iodo dash. What is on the second? On the second is methyl. What? So that's the name of the compound. One iodo, two methyl propane. One iodo, two methyl propane. On the first carbon, there's iodo. On the second carbon, there is methyl. Main chain, propane. That's it. Let's go here. What's the main? All the time start with the main name. We are on this one. Still propane. Propane. Numbering jet chain, 1, 2, 3. 1, 2, 3. Common, 2, 2, whichever direction we take. Okay, 2 is playing a key role. So here we are going to say, okay, two iodo, 2 methyl propane. 2 iodo, 2 methyl propane. It looks complex, but very easy. Why? Because you understand the naming of alkanes. Remember what I said? If you miss the nomenclature or naming of alkanes, where you are going to be stuck because you'll be confused. Why are we saying propane, butane? Because it's coming from the original family. So these are called haloginoalkanes or alkanes. Okay? Saturated. Why saturated compounds? Single, single, single. All right. And these are isomers. It's the same molecular formula, but just different positions, isomers. So even when we get down to, what's the time? Oh, when we get down to halogenation of alkenes, okay? Alkenes, halogenation. That is the addition of halogens from group 7 to alkenes. This is where we are going to end up. Okay? This is where we're gonna end up. For instance, okay, hydrogen 1, 2, 3, 4. 1, 2, 3, 4. Okay? This is propene. Not propane now. Propene. Is it? As an alkene. So if we add, let's say, bromine. Now we are going to go with bromine. Okay, bromine molecule, which is Br2, isn't it? This is the same as Br and Br. Remember, 1 dash, 2 electrons. 1 electron from here, the other one from this one. Hey, brother, what are we doing? Let's attack propene. Let us saturate propene. Propene is unsaturated. by virtue of the presence of this double bond. So they're not coming to attack this bond. No, very strong, very strong. Okay, but this is a weaker bond. It's the one which takes part in the chemical reaction. So electron here, here. This is gonna go with that. This is gonna go with that. Okay? Which is the same as this, because this electron belongs to here. Okay? And this one belongs to here. Okay? I haven't removed, you are not removing any hydrogen. You're just adding. That's why it's called additional reaction, because it is saturated. Unsaturated double bond, you just add and maintain the hydrogens. Okay? Remember the hydrogen here, you can bring it here. So now from propene to bromine is abbreviated bromo. Okay? Bromo. So in general, you can say propane. From propene, it becomes propane. Why? Single bonds. Double bond is gone. Okay? Double bond is gone. It's broken by these two guys, rendering it propane. You get a point? It becomes propane. So already you can see how many? There are two. So it will be dibromo. Okay? So this is dibromo. Dibromopropane, meaning two bromine atoms inside propane. That's it. For this simpler structure, you can just leave it like this without putting the numbers, because if you take this one and put it here, it's the same as this one. So this is dibromopropane. By argument's sake, if you want to put the numbers, positioning, it's going to be 1, 2, 3, or 1, 2, 3. It's the same. Okay? Not the same, sorry. It's different because it's attached on the bromo is attached here. So you are going to go with 1, comma, this one on the second 2, dibromopropane. That's it. 2 dibromopropane. Okay, if there are circumstances with another, there are 3. You're just going to say 1, 2, 3, tribromopropane. Easy, it becomes even boring when you know where you're coming from. Okay, so we're gonna end here on halogenation of unsaturated compounds or alkenes. Same formula. It's the same. Takes you back to the alkanes. So this is nomenclature. All right. So now you can, when we come to alcohols, okay, please write down this. I want you to research on alcohols. Write down this. Structures of alcohols. So I want you to research on alcohols with 1 to 6 carbons. Okay. Your homework is name the simplest alcohols with 1 to 6 carbons. Okay. 1 to 6 carbons. 2, that's number 1. Write and name the structures of alcohols with 1 to 6 carbons. Number 2 question. What is the functional group of alcohols. What's the functional group of alcohols? You know the functional for alkenes, we said this. Functional for alkanes, we said this, isn't it? Alkynes, we said this. What about alcohols? Research on that one. So this is the end of our organic chemistry for today. Oh, it's stopped recording. Still recording. Still recording. Okay. Super. It's good attendance today. I can see Paulo Blessed, Melda, Anita, Gift, Unknown, Webby, Yola Sebele. So God bless you. And tomorrow there is different modules to learn. I stop recording here. Evans Lukomona from Germany, CHU. Salam. Sir, you said you will send an assignment back to the. Oh, okay. Yeah, in fact, the assignment I wanted to send you was to research about halogenoalkanes, what we have discussed. Okay, wonderful. So, bye bye. And we've got to wait for the English people.